Chapter 11 of Agriculture for Beginners. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. Agriculture for Beginners by Charles William Burkett. Section 60. The Dairy Cow. Success in dairy farming depends largely upon the proper feeding of stock. There are two questions that the dairy farmer should always ask himself. Am I feeding as cheaply as I can? And am I feeding the best rations for milk and butter production? Of course, cows can be kept alive and in fairly good milk flow on many different kinds of food, but in feeding, as in everything else, there is an ideal to be sought. What, then, is an ideal ration for a dairy cow? Before trying to answer this question, the word ration needs to be explained. By ration is meant a sufficient quantity of food to support properly an animal for one day. If the animal is to have a proper ration, we must bear in mind what the animal needs in order to be best nourished. To get material for muscle, for blood, for milk, and for some other things, the animal needs, in the first place, food that contains protein. To keep warm and fat, the animal must, in the second place, have food containing carbohydrates and fats. These foods must be mixed in the right proportions. With these facts in mind, we are prepared for an answer to the question, what is an ideal ration? First, it is a ration that, without waste, furnishes both in weight and bulk of dry matter a sufficient amount of digestible, nutritious food. Second, it is a ration that is comparatively cheap. Third, it is a ration in which the milk-forming food, protein, is rightly proportioned to the heat-making and fat-making food, carbohydrates and fat. Any ration in which this proportion is neglected is badly balanced. Now test one or two commonly used rations by these rules. Would a ration of cottonseed meal and cottonseed hulls be a model ration? No. Such a ration, since the seeds are grown at home, would be cheap enough. However, it is badly balanced, for it is too rich in protein. Hence, it is a wasteful ration. Would a ration of cornmeal and corn stover be a desirable ration? This, too, since the corn is home-grown, would be cheap for the farmer, but, like the other, it is badly balanced, for it contains too much carbohydrate food and is therefore a wasteful ration. A badly balanced ration does harm in two ways. First, the milk flow of the cow is lessened by such a ration. Second, the cow does not profitably use the food that she eats. The following table gives an excellent dairy ration for the farmer who has a silo. If he does not have a silo, some other foods can be used in place of the ensilage. The table also shows what each food contains. As you grow older, it will pay to study such tables most carefully. Digestible matter for different types of feedstuff. Cowpea hay, 15 pounds. Footnote. Alfalfa or clover hay may take the place of cowpea hay. End of footnote. Dry matter, 13.5. Protein, 1.62. Carbohydrates, 5.79. Fat, 0.16. Corn stover, 10 pounds. Dry matter, 5.95. Protein, 0.17. Carbohydrates, 3.24. Fat, 0.07. Corn ensilage, 30 pounds. Dry matter, 6.27. Protein, 0.27. Carbohydrates, 3.39. Fat, 0.21. Cottonseed meal, 2 pounds. Dry matter, 1.83. Protein, 0.74. Carbohydrates, 0.33. Fat, 0.24. Total equaling 57 pounds consists of dry matter, 27.55. Protein, 2.80. Carbohydrates, 12.75. And fat, 0.68. Care of the cow. As the cow is one of the best money makers on the farm, she should, for this reason, if for no other, be comfortably housed, well fed and watered, and most kindly treated. In your thoughts for her well-being, bear the following directions in mind. 1. If you are not following a balanced ration, feed each day several different kinds of food. In this way, you will be least likely to waste food. 2. Feed at regular hours. Cows, like people, thrive best when their lives are orderly. 3. Milk at regular hours. 4. Brush the udder carefully with a moist cloth before you begin to milk. Cleanliness in handling makes the milk keep longer. 5. Always milk in buckets or cups that have been scalded since the last using. The hot water kills the bacteria that collect in the dents or cracks of the utensil. 6. Never let the milk pail remain in the stable. Milk rapidly absorbs impurities. These spoil the flavor and cause the milk to sour. 7. Never scold or strike the cow. She is a nervous animal, and rough usage checks the milk flow. Section 61. Milk, cream, churning, and butter. Milk. Milk is, as you know, nature's first food for mammals. This is because milk is a model food. It contains water to slake the thirst, ash to make bone, protein to make flesh and muscle, and fat and sugar to keep the body warm and to furnish energy. The different kinds of milk. Whole or unskimmed milk, skimmed milk, and buttermilk are too familiar to need description. When a cow is just fresh, her milk is called colostrum. Colostrum is rich in the very food that the baby calf needs. After the calf is a few days old, colostrum changes to what is commonly known as milk. The following table shows the composition of each of the different forms of milk. Composition of milk, listing the digestible matter in 100 pounds. Colostrum, dry matter 25.4, protein 17.6, carbohydrates 2.7, fat 3.6. Milk unskimmed, dry matter 12.8, protein 3.6, carbohydrates 4.9, fat 3.7. Skimmed milk, dry matter 9.4, protein 2.9, carbohydrates 5.2, fat 1.3. Buttermilk, dry matter 9.9, protein 3.9, carbohydrates 4.0, fat 1.1. A noticeable fact in this table is that skimmed milk differs from unskimmed milk mainly in the withdrawal of the fat. Hence, if calves are fed on skimmed milk, they should have in addition some food like cornmeal to take the place of the fat withdrawn. A calf cannot thrive on skimmed milk alone. The amount of nourishing fat that a calf gets out of enough milk to make a pound of butter can be bought in the form of linseed or cornmeal for a very small amount, while the butter fat costs, for table use, a much larger sum. Of course, then, it is not economical to allow calves to use unskimmed milk. Some people undervalue skimmed milk. With the addition of some fatty food, it makes an excellent ration for calves, pigs, and fowls. Along with its dry matter, its protein, its carbohydrates, and its fats, milk and its products possess another most important property. This property is hard to describe, for its elements and its powers are not yet fully understood. We do, however, know certainly this much. Milk and the foods made from it have power to promote health and favor growth in a more marked degree than any other foods. It is generally agreed that this is due to the health-promoting and health-preserving substances which are called vitamins. Men of science are working with much care to try to add to our knowledge of these vitamins, which have so marvelous an influence on the health of all animals. Unless food, no matter how good otherwise, contains these vitamins, it does not nourish the body nor preserve bodily health as it should. A complete lack of vitamins in our food would cause death. Since, then, milk and its products, butter, cheese, curds, are rich in vitamins, these health-giving and health-preserving foods should form a regular part of each person's diet. Cream. Cream is simply a mixture of butterfat and milk. The butterfat floats in the milk in little globe-shaped bodies or globules. Since these globules are lighter than milk, they rise to the surface. Skimming the milk is a mere gathering together of these butterfat globules. As most of the butterfat is contained in the cream, pains should be taken to get all the cream from the milk at skimming time. After the cream has been collected, it must be allowed to ripen or sour in order that it may be more easily churned. Churning is only a second step to collect in a compact shape the fat globules. It often happens that at churning time the cream is too warm for successful separation of the globules. Whenever this is the case, the cream must be cooled. The churn. Revolving churns without inside fixtures are best. Hence, in buying, select a barrel or a square box churn. This kind of churn brings the butter by the falling of the cream from side to side as the churn is revolved. Never fill the churn more than 1/3 or 1/2 full of cream. A small churn is always to be avoided. Churning. The proper temperature for churning ranges from 58 degrees to 62 degrees Fahrenheit. Test the cream when it is put into the churn. If it be too cold, add warm water until the proper temperature is reached. If too warm, add cold water or ice until the temperature is brought down to 62 degrees. Do not churn too long, for this spoils butter. As soon as the granules of butter are somewhat smaller than grains of wheat, stop the churn. Then draw off the buttermilk, and at a temperature as low as 50 degrees wash the butter in the churn. This washing with cold water so hardens the granules that they do not mass too solidly and thus destroy their grain. Butter. The butter so churned is now ready to be salted. Use good fine dairy salt. Coarse barrel salt is not fit for butter. The salt can be added while the butter is still in the churn, or after it is put upon the butter worker. Never work by hand. The object of the working is to get the salt evenly distributed and to drive out some of the brine. It is usually best to work butter twice. The two workings bring about a more even mixture of the salt with the butter and drive off more water. But one cannot be too particular not to overwork butter. Delicate coloring, attractive stamping with the dairy owner's special stamp, and proper covering with paper cost little, and of course add to the ready and profitable sale of butter. Dairy rules. Stables and cows. Whitewash the stable once or twice each year. Use land plaster, muck, or loam daily in the manure gutters. 2. On their way to pasture or milking place, do not allow the cows to be driven at a faster gait than a comfortable walk. 3. Give abundance of pure water. 4. Do not change feed suddenly. 5. Keep salt always within reach of each cow. Milking. 1. Milk with dry hands. 2. Never allow the milk to touch the milker's hands. 3. Require the milker to be clean in person and dress. 4. Milk quietly, quickly, thoroughly. Never leave a drop of milk in the cow's udder. 5. Do not allow cats, dogs, or other animals around at milking time. Utensils. 1. Use only tin or metal cans and pails. 2. See that all utensils are thoroughly clean and free from rust. 3. Require all cans and pails to be scalded immediately after they are used. 4. After milking, keep the utensils inverted in pure air and sun them, if possible, until they are wanted for use. 5. Always sterilize the churn with steam or boiling water before and after churning. This prevents any odors or bad flavors from affecting the butter. All cans, pails, and bottles should also be sterilized daily. Section 62. How milk sours. On another page you have been told how the yeast plant grows in cider and causes it to sour, and how bacteria sometimes cause disease in animals and plants. Now you must learn what these same living forms have to do with the souring of milk, and maybe you will not forget how you can prevent your milk from souring. In the first place, milk sours because bacteria from the air fall into the milk, begin to grow, and very shortly change the sugar of the milk to an acid. When this acid becomes abundant, the milk begins to curdle. As you know, the bacteria are in air, in water, and in barn dust. They stick on bits of hay and stick to the cow. They are most plentiful, however, in milk that has soured. Hence, if we pour a little sour milk into a pail of fresh milk, the fresh milk will sour very quickly, because we have, so to speak, seeded or planted the fresh milk with the souring germs. No one, of course, ever does this purposefully in the dairy, yet people sometimes do what amounts to the same thing. That is, put fresh milk into poorly cleaned pails or pans, the cracks and corners of which are cozy homes for millions of germs left from the last sour milk contained in the vessel. It follows, then, that all utensils used in the dairy should be thoroughly scalded so as to kill all germs present, and particular care should be taken to clean the cracks and crevices, for in them the germs lurk. In addition to this thorough cleansing with hot water, we should be careful never to stir up the dust of the barn just before milking. Such dusty work as pitching hay or stover or arranging bedding should be done either after or long before milking time, for more germs fall into the milk if the air be full of dust. To further avoid germs, the milker should wear clean overalls, and should have clean hands, and above all should never wet his hands with milk. This last habit, in addition to being filthy, lessens the keeping power of the milk. The milker should also moisten the parts of the cow which are nearest to him, so that dust from the cow's sides may not fall into the milker's pail. For greater cleanliness and safety, many milkmen curry their cows. The first few streams from each teat should be thrown away, because the teat at its mouth is filled with milk which, having been exposed to the air, is full of germs, and will do much toward souring the other milk in the pail. Barely a gill will be lost by throwing the first drawings away, and this of the poorest milk too. The increase in the keeping quality of the milk will much more than repay the small loss. If these precautions are taken, the milk will keep several hours or even several days longer than milk carelessly handled. By taking these steps to prevent germs from falling into the milk, a can of milk was once kept sweet for 31 days. The work of the germ in the dairy is not, however, confined to souring the milk. Certain kinds of germs give to the different sorts of cheeses their marked flavors and to butter its flavor. If the right germ is present, cheese and butter get a proper flavor. Sometimes undesirable germs gain entrance and give flavors that we do not like. Such germs produce cheese or butter diseases. Bitter butter is one of these diseases. To keep out all unpleasant meddlers, thoroughly cleanse and scald every utensil. Exercise. What causes milk to sour? Why do unclean utensils affect the milk? How should milk be cared for to prevent its souring? Prepare 2 samples, one carefully, the other carelessly. Place them side by side. Which keeps longer? Why? Section 63. The Babcock Milk Tester. It is not sufficient for a farmer or a dairyman to know how much milk each of his cows yields. He should also know how rich the milk is in butterfat. Wide-awake makers of butter and cheese now buy milk, not by the pound or by the gallon, but by the amount of butterfat contained in each pound or gallon of milk. A gallon of milk containing 4.5% of fat will consequently be worth more than a gallon containing only 3% of fat. So it may happen that a cow giving only 2 gallons of milk may pay a butter maker more than a cow giving 3 gallons of milk. Of course, it is easy to weigh or measure the quantity of milk given by a cow, and most milkers keep this record. But until recent years there was no way to find out the amount of fat in a cow's milk except by a slow and costly chemical test. Dairymen could only guess at the richness of milk. In 1890, Dr. S. M. Babcock of the Wisconsin Experiment Station invented a wonderful little machine that quickly and cheaply measures the fat in milk. Few machines are more useful. So desirous was Dr. Babcock of helping farmers that he would not add to the cost of his machine by taking out a patent on his invention. His only reward has been the fame won by the invention of the machine which bears his name. This most useful tester is now made in various sizes, so that every handler of milk can buy one suited to his needs and do his own testing at very little cost. The operation of the machine is very simple. Suppose that the members of the class studying this book have been asked to take a Babcock machine and test the milk of a small herd of cows. They can readily do so by following these directions. While the milk is still warm from the first cow to be tested, mix it thoroughly by pouring it at least 4 times from one vessel to another. A few ounces of this mixed milk is then taken for a sample and carefully marked with the name of the cow. A number is also put on the sample, and both the cow's name and number entered into a notebook. A small glass instrument, called a pipette, comes with each machine. Put one end of the pipette into the milk sample and the other end into the mouth. Suck milk into the pipette until milk comes up to the mark on the side of the pipette. As soon as the mark is reached, withdraw the pipette from the mouth and quickly press the forefinger on the mouth end. The pressure of the finger will keep the milk from running out. Then put the lower end of the pipette into one of the small long-necked bottles of the machine and, lifting the finger, allow the milk to flow gently into the bottle. Expel all the milk by blowing through the pipette. The next step is to add a strong biting acid, known as sulfuric acid, to the test bottle into which you have just put the milk. A glass marked to show just how much acid to use also comes with the machine. Fill this glass measure to the mark. Then pour the acid carefully into the test bottle. Be sure not to drop any of the acid on your hands or your clothes. As the acid is heavier than the milk, it will sink to the bottom of the bottle. With a gentle whirling motion, shake the bottle until the 2 fluids are thoroughly mixed. The mixture will turn a dark brown and become very warm. Now fill the other bottles in the same way with samples drawn from different cows. Treat all the samples precisely as you did the first. Do not forget to put on each sample the name of the cow giving the milk, and on each test bottle a number corresponding to the name of the cow. You are now ready to put the test bottles in the socket of the machine. Arrange the bottles in the sockets so that the whirling frame of the machine will be balanced. Fit the cover on the machine and turn the handle slowly. Gradually gain in speed until the machine is whirling rapidly. Continue the turning for about 7 minutes at the speed stated in the book of directions. After this first turning is finished, pour enough hot water into each test bottle to cause the fat to rise to the neck of the bottle. Recover the machine and turn for 1 minute. Again add hot water to each bottle until all the fat rises into the neck of the bottle, and again turn 1 minute. There remains now only the reading of the record. On the neck of each bottle there are marks to measure the amount of fat. If the fat inside the tube reaches only from the lowest mark to the second mark, then there is only 1% of fat in this cow's milk. This means that the owner of the cow gets only 1 pound of butter fat from each 100 pounds of her milk. Such a cow would not be at all profitable to a butter seller. If the fat in another test bottle reaches from the lowest mark to the fourth mark, then you put in your record book that this cow's milk contains 4% of butter fat. The record shows that the second cow's milk yields 4 pounds of fat for every 100 pounds of milk. This cow is 3 times more valuable to a butter maker than the first cow. In the same way, add 1 more percent for each higher mark reached by the fat. 4 1/2% is a good record for a cow to make. Some cows yield as high as 5 or 6%, but they do not generally keep up this record all the year. The Babcock tester shows only the amount of pure butter fat in the milk. It does not tell the exact amount of finished butter which is made from 100 pounds of milk. This is because butter contains a few other things in addition to pure butter fat. Finished and salted butter weighs on an average about 1/6 more than the fat shown by the tester. Hence, to get the exact amount of butter in every 100 pounds of milk, you will have to add 1/6 to the record shown by the tester. Suppose, for example, you took one sample from 600 pounds of milk, and that your test showed 4% of fat in every 100 pounds of milk. Then, as you had 600 pounds of milk, you would have 24 pounds of butter fat. This fat, after it had been salted and after it had absorbed moisture as butter does, will gain 1/6 in weight. As 1/6 of 24 is 4, this new 4 pounds must be added to the weight of the butter fat. Hence, the 600 pounds of milk would produce about 28 pounds of butter. Exercise 1. Find the number of pounds of butter in 1,200 pounds of milk that tests 3% of butter fat. 2. A cow yields 4,800 pounds of milk in a year. Her milk tests 4% of butter fat. Find the total amount of butter fat she yields. Find also the total amount of butter. 3. The milk of 2 cows was tested. One yielded in a year 6,000 pounds of milk that tested 3% fat. The other yielded 5,000 pounds that tested 4%. Which cow yielded the more butter fat? What was the money value of the butter produced by each if butter fat is worth 25 cents a pound? End of chapter 11.